Okay, so we will start. First of all, I will follow. There's no point on doing new slides on ITK because a lot of people has done very good slides on how to install ITK, what is the structure of ITK, etc., etc. But I've done some introductory slides from my side, let's say, kind of what we are going to do and how we're going to do it and what we're going to, let's say, the structure. What is going to be the structure of this short course. This is quite short. Okay. By the way, if you have any questions, anything that you want to know, just raise your hand. And yeah, I don't want it to be, a lecture that I just talk and you do. Okay? All right. So, by the way, you know me, I'm Robert Martí. We met in the induction week, I guess.
Yes.
All right. But just in case you forgot. And, well, forgive me, don't remember. I remember the faces, but I'm very bad at names. So, I will mix the names and in anything. Okay? So, what we are going to do, we're going to have a short introduction to ITK and its models. The idea is that ITK is a very good platform to develop the image analysis software. We'll see that it's quite focused to medical image analysis, but you can do any image analysis that you want. But also it's a good excuse to learn how to program and develop software in open source cross platforms. Okay? Most of the time you are used to things which are quite, let's say, close, like MATLAB and things like this. And probably from these, let's say, prototypes to a software that can be deployed to a clinical practice, if we're thinking now in medical imaging, most of the time those platforms, or closed platforms, are not the most suitable ones. Okay? So learning how to use this kind of software, it's also interesting. And this will mean that will be hopefully today's 1.5 hours or 2 hours, we'll see, how to install and use the different, install and use ITK for different image analysis tasks. Okay? As I said, we'll follow the ITK slides and tutorials. There are lots of different things published, webinars, so there's a lot of things you can learn from. But instead of just showing you this, I think it's good to have a hands-on workshop. That's going to be useful for today. If we have time, during all these days, we'll do several examples as well. Hopefully the Hello World example will be done today, okay? But we'll do also basic image input and output, basic filtering. We'll see something about the Inside Journal, which is quite interesting with basic filtering. We'll see methods for image segmentation, image registration. We'll do a sort of, if we have time, some sort of a longer project in image segmentation and evaluation, etc., etc. I'm assuming that you know a little bit of image segmentation, some methods. You know thresholding, I'm assuming as well you know something about filtering, you know how to remove noise, you know how to extract edges and things like this. Yes?
Yes.
So I'm not going to go, the idea of today is not to do a lot of different algorithms, complex things, etc., etc. It's to know the tools. So we are going to use the algorithms that you already know, and we're going to use them in ITK and see how they work. Okay? So it's not going to, you're not going to learn much on image analysis, let's say methods, etc., but on tools to use those methods. Okay? Hopefully. Okay, so what is ITK? Okay, it's an open source and closed platform library, as I already said, for, let's say, medical. The idea was to do it for medical image analysis, but you can do any analysis or image analysis that you want to do. And incorporates different models from pre-processing, input and output, segmentation, and registration. You know what registration is? What registration is?
Yes.
Yes? Sorry? Fine? Sorry?
Like when you want to find an object.
When you want to find an object in image?
Combine image from different scanners and try to make that as one.
Okay. You can find an object in image, but the main characteristic of image registration is you are not working with one image. You're working with two images at least, or several images of the same area or the same thing that you want to analyze. And for instance, you want to check the difference between the two images. Okay? One way to check the difference between two images will be do a subtraction. No? Very basic thing. But if those images are not aligned, this subtraction will highlight movement or differences that are due to misalignment. Okay? Registration, it's a very vast, let's say, research field, no? But the idea is that the registration tries to align the images to compensate for, let's say, spatial differences, to highlight the interesting differences of it is an object, or it is a lesion that has grown, or a lesion that has disappeared, etc., etc. Okay? So registration basically compares two or more images in order to analyze the changes in an image. Okay? So ITK has a lot of implementations on registration algorithms as well. But as I said, maybe if we don't have time to do registration, you'll see it when you come to Girona. And we'll see specifically registration. There's a full model on image registration. Okay? Another thing is, ITK is organized in models, so you'll see different kinds of models. Inside each of the models, there is a large number of methods, parameters, etc., that you can explore. Okay, and it's also highly template-based, which means that it's very modular in the sense that you can have images that are binary images, or 2D images, or 3D images, or float images, and you don't need to have different, let's say, objects for that. You'll have the same object, but you just put a parameter of this image is float, this image is in, this image is 2D, this is 3D, etc., etc. Okay? Have you used C++ before? Have you programmed C++ before?
Yep.
Yes? Everybody? Who hasn't? You can raise your hand, no problem. No? Everybody has some notions, okay? The idea is, as well, we're not going to do C++ programming course. We're going to need C++ notions to use ITK, okay? But you'll see that it's not really complicated. Well, this is just to see the complexity of ITK, okay? If we put the different models here, there are a lot of different things, but you'll see also the interconnection in the sense that some models use another model, or some model has 2-3 models that are inside this class, etc., etc. If you know a little bit about object-oriented programming, you know a bit of class diagrams and things like this. This want to show a little bit the interrelationship between the different models. Okay? It's just to show that it's very complex and very fancy. Okay. So, what are we going to use? It's going to be, this is kind of a summary of all these things. We're going to use the ITK libraries, obviously. Okay? As I said, we could download the already compiled binaries and all these things. But this has also some problems. It depends on the platform that you use. It might have some difficulties to link, etc., etc. So I thought also to learn how to compile, to learn how to use CMake and all these things. I thought it was a good exercise to spend some time doing this installation from scratch, let's say. Okay? So we'll download ITK libraries. We'll download a tool which allows you to do this cross-platform compilation of files. Okay? This is called CMake. All right? So we have to download CMake as well. You need a C++ compiler, as I said at the beginning. So you have a Visual Studio, GCC, or anything in Linux, I think, or OS X. You can use. Any will do. Okay? If you don't have it, or if you look at the slides afterwards, you can go to this link to download the Visual. I use the 2013, but you can use 2012 up to 2017 or whatever. Okay? This is the full name I'm using because they have very fancy names. So Visual Studio Express 2000 Windows, okay, with update 5. All right? There are PDF files as well that help you to understand a little bit of the concepts that are not clear. Okay, hopefully those days I'll be able to answer them, but afterwards, if you have some problems, you can contact me, but also you can have a look at this software guide. It's very extensive, so explains almost everything, but it's around 500 or 600 pages each of the PDFs, so it's quite a good thing to use if you cannot sleep at night. Okay. Another thing we're going to use is ITK Snap. So ITK Snap, it's not part of ITK as such. It's kind of a standalone application, but it's good for visualizing data. Okay, it's a kind of visualizer. I can show you, or I can show you now probably. So that's ITK Snap. Okay, you see it? Okay. So ITK Snap. It's a good tool to visualize the data we are using. Okay, this is an example of the data we're going to use those days. This is what you know. What is this? Any idea? Knee? Yeah, it's a knee. Okay, a femur, a tibia, and well, the muscles, etc., etc. Do you know which modality is? Which type of image? X-ray, an MRI, an ultrasound?
Not ultrasound.
Not an ultrasound. You know what is not, but MRI? Who says MRI? 1, 2, 2.5, 3. Yeah? Yes, it is an MRI, so you were right. Okay. Well, that's one of the images we're going to use, so you'll see that you can, this ITK Snap, we're not going to be focusing on displaying or building software to display the images. Okay? When you come to Girona, you'll see that some of the models, eHealth model in particular, will have some, let's say, some labs and something devoted to this displaying the image information and all these things. We are more interested in developing image analysis, so applying algorithms to the images in order to extract some information. Mm-hmm. So the part of visualization, we can use tools like these ones that are quite good and much better than the ones we can develop in a very short period of time. Okay? So that's another thing we have to use, or we will use. If I go back to the slides, that's ITK Snap. And also, the last bit is very important. You need patience and a cup of coffee or tea if you prefer. Okay? Especially for compiling for today's class. Hopefully, it's going to be quick. But you might have some problems with some of the compilations. It can take some time as well, etc., etc. Okay? So, one of the questions will be why we use ITK or what we can do with ITK. All right? As I said, we can do lots of different things. You'll see that if I go to this link, this is Doxygen is kind of a way of documenting source code, okay, which is, let's say, is automatically done when you program the source code. You put some comments in your source code and you can generate the HTML files about the structure of your classes and the software you developed, okay. And this is Doxygen 4.13. This is the version of ITK we're going to use. Well, 4.13, sorry. And then you can have all the information here. So basically, if you want to use something, you probably go to the models that you want to use, and you say, okay, I want to do, for instance, segmentation. Okay, I'm looking into this in the sense that you don't know exactly what you're going to use, so you need to know what is the name of the model. For instance, you know about region growing? Yes? What is region growing?
It's an algorithm used in one of its applications in phase and wrapping.
Sorry, in what?
Phase and wrapping.
Phase?
Yes.
Okay.
Phase and wrapping for MRI images, and it's used like you put a seed, and this seed will grow like dramatically to cover one area you're looking for.
Yeah. Everybody remembers this? Or you've done that in...
This was like a project.
Okay, all right. So the idea of, it's a segmentation algorithm. Segmentation, it tries to divide the images into regions. And one of these algorithms is region growing in the sense that you start from a seed point and you grow the region. You grow the region incorporating pixels that are similar to this seed point. No? Okay? All right. So we can go here and use region growing. We can go here and you'll see that this is region growing. It tells you that this model contains classes to perform region growing approach to image segmentation. A seed pixel is iteratively propagated to a region identified, blah, blah, blah. Okay? So this links to what you know already. So you will go here and you say, okay, how do I use this? Well, there are different things. There is, for instance, confidence connected image, threshold image, isolated component image, etc., etc. Okay, you will start looking at this I know that it starts to look a bit complicated, okay? But also you could look at examples. So we're going to see that in a minute, okay? But it's just to, you could do some examples. You want to go to segmentation, and you could use and see well, isolated content, which is an example. We're going to see that, all right? But this is an example of how image segmentation could be used. Sorry? I guess I could, yeah. Something like this. Okay? And this is an example of a working example of how to use this filter. Okay? Don't look so scared. We're going to go step by step. Okay? What I'm saying is that there's a lot of things that you can use, and sometimes you have the impression that you are getting lost. But, well, go step by step. Search for what you want to do, the filter, the name, and then search for an example of this using it. Run the example and see what are the effects of the parameters, etc., and then you can incorporate this piece of code into your examples. Yeah?
Are you using LaTeX?
Well, this LaTeX thing is used to generate then, for instance, the software guide, a PDF file. Okay? So those are comments. This is quite also interesting. You develop your source code, and this LaTeX is kind of extracted from source code and generates a PDF or something like this. Okay? So basically everything comes from the source code, but depending on the comments that you put, then it generates different types of information. Okay? Okay, so as I said, we'll go step by step. Don't worry too much. Okay? But it's just an example of how to see the different models. You go and search for a specific filter, algorithm, etc., and you will find the example how to use it. Okay? Okay, and then you'll find, for instance, here there's a relationship between the different models or different classes if you want. Region grouping uses thresholding uses the image intensity and statistics from the image. Okay, so you can have also a visual interpretation of this. Then I say, should we start? Okay, now I've talked a little bit. Okay, so first thing you could do is go and download from each of the web pages. Okay, but hopefully, if you go to this link, this is a Google Drive link, you should be able to download, well, if I go myself to this, that's much easier. So this activates this, and I click on this. Okay, so why is this happening now? Oh, come on. Anyway. Not very useful. So I can use another one. It worked before, 5 minutes before. So I can click on this. And I can go to this. And here you'll find these slides, okay? The ones that just, there are not many. You'll have two data files. One is a knee and the other one is a mammography image. Okay, you can download them and you'll have different examples. Okay, I would suggest now to go to software. Okay, let me write down the address. So it's shortened Okay, so everybody should be able to get into this. Okay, is everybody able to access this? Okay, you can start downloading the software. If I go here, inside the software you'll see a CMake. Okay, if you're using Windows, if you're using Linux, there's also CMake for Linux or for Mac. Okay, but you have to go to cmake.org and download it from there. Okay, those are the two PDFs about the software guides. You can download them as well. And the important bit here is what is called Inside Toolkit, which is the ITK libraries, the source libraries. Okay, don't know if you see them.
Yes.
If you already have CMake installed, you mean? No need to, because you use it for OpenCV probably? Okay. So you know about CMake? How it works?
Yeah.
What does that mean? You know how to do a CMake list? Okay, so you don't know CMake. You know how to run it, but you don't. No, I'm joking, but it's not very complicated. But we need to talk a little bit about this. And you can download ITK Snap, which is this visualization thing. One is 32 bits, and the other one is 64, just in case you have different systems. Okay?
Do we need VTK also?
You don't need VTK. Okay? VTK is for visualization, and it's similar to, it's a nice complement to ITK. So you do processing in ITK, and then you visualize with VTK, okay? But we're not going to cover VTK in this course, okay? You could also do it, you can investigate it after this course, but when you come to Girona, some of the models we're going to use VTK to do visualization. Okay? So you can start downloading this and installing. Install, CMake, if you already have it, install a Snap, and download the ITK, the zip files, okay? I would suggest, you can do whatever you want, but I would suggest to put them into something like C, ITK. I'm talking about the source code, okay? Here, and then once you extract, it will create this structure, okay? This is all the source code of ITK into different folders. So you can go to, as I said, it's structured in models, so you can go to models. You can go to registration. No, not registration. We are talking about the segmentation. You want to know how is implemented the region growing. You go there. You go to include, and you could go to, those are the include ones. Well, region growing should be here. Well, it is separated in different folders, so I guess neighborhood connected. You could have a look at how it's implemented. Okay? And you'll see there's a lot of different things that probably are a bit strange. Okay? It would be good, then we're going to go into these details, okay? It would be good if you know a little bit about classes, because classes, you have, everything is developed in class. So a class called neighborhood connected component, it has different types, it has different methods, etc., etc. Is somebody familiar with object-oriented programming? More or less? Okay. So you know the concept of an object. That object has some structures inside about the data and the methods that you can use. Mm-hmm. Yeah? So one object can have another object inside and use that object being public, being private, and things like this. Okay. I don't want you to know more than that. Okay. So as I was suggesting, probably your setup installation folder, your basic installation folder for ITK can be C/ITK. So you put the source code there and you extract it. Okay? One thing we'll learn about this, and I think it's a very good practice, is to separate source code from binaries or whatever it's depending on your platform. And that's very important if you're doing multi-platform programming. So one thing will be your source code that is going to be valid for any platform, any software, anything. Yeah? And then it will be the specific files depending on the compiler that you use, etc., etc. Okay? So we're going to separate things. This is going to be done in CMake, so we're going to see how we do that. Okay? And then what we'll do is compile the ITK libraries. We'll do CMake. We'll need some space, some GBs. Okay? I don't know how is your laptop in terms of space. I know that that's a really difficult thing to have. But we'll see. We'll try to make it very small, but the very small means 1-2 gigs. Okay? That's why I'm saying you don't need to compile on needed parts, examples, tests, and all these things, because that will take more space. There are options as well. We're going to see that. So don't worry about this. I'm just saying things now that we're going to see in a minute. That there are 2 ways to compile the libraries and 2 ways to compile once you do your program. Okay, you'll compile it for debugging if you are starting to do your program to be able to put breakpoints and see how the program is running. Okay, debug is good to debug the code, but it's bad in terms of being a fast program. It's a bit slower than if you don't do debug. And I forgot the second thing I wanted to say. And also it takes more space, the executable. Okay? So once you develop your program and you compile it for debug, and you're sure that it works, you'll compile it for release. And for release, we'll make the program run faster. Okay? So if you want to do debug and release in your software, and you want to do debug in ITK, you need to compile for debug and you need to compile for release. All right? But that means double the space because you need to compile for debug and for release. We'll do one. You will do debug, for instance, and we won't do release, but you can do both if you want. Okay? For instructions of Mac, well, I think I could have this bigger. For instruction of Mac, how to install Mac, is you can follow this link. And in Ubuntu Linux, it's quite extensive, these things. Okay? So after we finish installing the libraries, there's one thing before we start programming. There's one thing we need to set up is the ITK environment variable. We're going to see that in a minute. So the idea of today, if we are able to finish, I think we should. Okay, yes, I think we should be. The idea is to do a hello world example, as in any language that you start programming with. Okay? There are 2 things that we're going to use. The source code, this hello world.cxx, okay? And then a CMake list. CMake list is let's say the file that is going to tell the CMake, which is the cross-platform compiler, that would generate the cross-platform files for compilation, in order to say what is the source code, what the libraries do we need, etc., etc. Okay? This is also a cross-platform. So you, with only CMake list and Hello World, you should be able to compile in any different platforms, Windows, or Mac, or Linux. Okay? So just an example of what the CMake list looks like, and a very, very simple one. You have project, you name your project, we call it Hello World to be original. Then there's something that CMake makes us write, which means it's a CMake minimum required version, but this is something we have to put that. And then it's very easy to start using different libraries. Because we are only using ITK, we're going to say find package ITK required, and we're also going to say the include files of ITK. Okay? And then if we had more source files, we'll put the source files here, the source code files, but we only have one. You will generate an executable called hello world, and from compiling the hello world.cxx. Okay? The final hello world executable will be linked with these libraries, ITK libraries. Okay? So basically you have an include, which are the include files, and the ITK libraries that are the libraries you need to link with. Does it make sense, this CMake? It's quite simple. All right? Let's see the hello world example. The idea of, let's say today, it's to compile the ITK and then try to compile this hello world. Okay? Include ITK image. So we're using a module called ITK image or include file, which is the basic for using images. IOStream, it's a C++ standard library, let's say, or to go do input output this way, a standard cout / ITK hello world. Okay, this outputs this string to the standard output. Okay, and then this headline means new line. All right. So basically, this code, you know, C++, you know that it starts with the main. This is the main program. Okay. ITK will have lots of type def. You're going to see lots of type def. You know what type def is? You define a new kind of type, a new kind of variable, if you want. Well, not variable, type of variable. Yeah? You have ints. Sorry? Yeah?
Is it just a name for another, for like a long type?
Yes. Yeah. It's just that you are declaring a new type. You know, you have int, short, long, char, etc., strings, whatever. So basically, you will create a new type, so you can name this new type and use it afterwards. Okay, and this new type, in this case, for instance, instead of having to write all the time ITK dot image in unsigned short 3 blah blah blah, we name all this thing image type. Okay, so then we can say image type image and use it. Okay? So this first line, it's called type def ITK. That means we're going to use something which is in ITK. Maybe I can highlight. Yeah, this thing means, and it's quite common, to avoid, this is called namespace. So you can use, this is standard from C++, this is standard, let's say, for ITK. So you use ITK. We're going to use the image, okay? And as I said at the beginning, this is how you declare objects of a templated object. You're going to say, okay, I'm going to use images. Each pixel of the image will be an unsigned short. Okay? Mm-hmm. Does it make sense? Each pixel is unsigned short. Okay, not char. You could have char. You can unsigned char. You can have int. Mm-hmm. This is going to be unsigned short. And then 3. It's the dimension of the image. Okay? You could have 2, you could have 4, you could have 3. Dimensions means X and Y dimensions. Okay? We are not saying now how many pixels we have, but we are saying that we're going to use images of 3D images or 3 dimensions, X, Y, Z, and that each pixel in this image is going to be an unsigned short. Okay? Nothing else. Oops, sorry. Then we're going to call this new type image type, but you can call it whatever you want. Okay, that's the name you're going to give to your image type. Okay? And then, do you know about pointers a little bit in C++? We're going to use something which is, they call it the smart pointers, okay? Because it's a bit easier to use than the pointers in C. And plain C, where you had to do the new and allocate the memory, and if you didn't destroy it, then you have some leakage problems of blah blah blah. Okay, this is complicated. So memory problems and all these things. So this is how you were going to use most of the filters or most of the things in ITK. You're going to use the image type that we used before. Okay, the name of the type that we used before, and we're going to use pointers. So we put 2 points because we refer to this image type, and we're going to say this is going to be a pointer, okay? And this is going to be the name of the variable. In this case, we call it image. So this is our variable, okay? Yeah, the thing we're going to, in this case, load an image, save an image, etc., etc. Okay? Before we use this variable, we have to create it new, okay? So we use image type as the same type as this one, 2 semicolons, and then we type new. Okay, that creates the object. Yeah.
But usually we use the asterisk to define pointers. Why?
Yes. So you are not using asterisk in this sense to define pointers. You are using the new in this way. That's why the difference between normal pointers and smart pointers in that sense. Okay. So no need to use the asterisk and allocate the memory size. You remember that you put the size of blah 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 the type. You don't need to do that. Okay. But you need to declare that you want to use this. So that's the way. The image type, pointer image type. So 2 semicolons and new, and that creates the object, okay, calls the constructor. If you remember about this object-oriented programming, calls the constructor, creates the object, and puts that object in memory. Okay, so you can start using it. This is a dummy example, the hello world example. So it creates the object and is not using it. Okay, it's a stupid example if you would say that. But after this, we could use it. Okay, we could read the image, we could do pre-processing, we can do segmentation, we could do many things. We're gonna learn that step by step. Okay, but then what it says is using the standard cout to show messages, and it will say ITK hello world, new line, and then it returns exit sussex, which is a 0. All right, that's a normal C++ program. Okay. Easy? So, as you might, where is it? It's not there. Yeah, as you might know, once you compile this, maybe you can increase the... No, not the size. I can increase properties. Maybe it's more visible now. Once I compile, remember that this is our source code that we developed, and this needs to be done after. So first you need to compile ITK libraries, then once they are installed, you start developing your source code. Okay? So I'm going some steps ahead. After this, we're going to go and see how you can compile and how install the libraries and then try this. Okay? But this is what it's going to be doing. Hello world. Okay?
Okay.
So if we are able to do this, I'll be really very happy after this 1 hour left, I think. Okay? So if you just mention briefly, if you download the data, that's the data we're going to use. So it's in the same link as the Google Drive link that previously I gave it to you. We're going to use the DICOM data. You know about DICOM? You should know about DICOM. So that's an example of a DICOM file. We'll learn how to load the DICOM file, how to save the DICOM file, etc. We also use the NI MRI data that you saw before. It's not a DICOM, it's MHD file. So we'll see that we can load other types of files as well and save it in a different format. And I think that's it. Just, well, I used to incorporate some bibliography if you need. Okay, so the aim now will be to put to install the ITK libraries, compile them, and see that everything works up to the working hello world example. Okay? So I download the ITK source code in the C/ITK, download CMake, okay? And then, okay, yes. No, there's no need to do that. Okay? So, everybody has downloaded the source code in a C/ITK or whatever you want to put it. Yeah?
Yes.
Anyone needs help on that? No? Just stop me. If not, we'll try to replicate the same thing. So, I'll do this in the projector, and you can do that in the same thing in your laptop. Okay, so to start from the same, I have this C/ITK. Okay. See if I can make larger. Okay. All right. You might not have the bin. Okay. That's the first thing I want to have, separated source code from binary files, okay? Object files, libraries, and all these things that we generate from this source code, okay? So all the source code is here, and this is going to be generated by CMake, okay? So what I'll do is I'll go to CMake, okay? I browse the source code, which is going to be in ITK inside toolkit. Yes. I select this folder. And I browse where I want to put the binaries, which is going to be for me C/ITK/bin. Okay? If you don't have the /bin, you can create it, or you can put the names and CMake will create it for you. Okay? But you click on select folder. You should have something like this. Yeah? I'm sorry I cannot make it larger. Sorry? Is it similar? You make sure that if you don't want to take a lot of space, that build examples is not clicked and build testing is not clicked. Otherwise, it will take more time to compile and more space at the end.
You selected like Visual Studio for the
Yeah.
generator of the project?
Because you click already in configure?
Yep.
Okay. So I'm not there yet. Okay?
Then see the...
If you don't configure, you don't have the option.
Yes. You don't have-
Okay. So you click on configure. So that's why I can delete the cache. Probably. Yeah. That's what you have. Because I did that. So if you type of configure, you have here to choose the compiler you have.
Yes.
Okay? In my case, it's Visual Studio Win64, but in your case, will be 2012. See that you have many of them. This is the CMake for Windows, the CMake for Linux, or the CMake for Mac will be similar. Okay? All right? Once you select this, it will take some time. You see that it's there. It's checking that all the needed tools to compile it are there. Okay? So now it's a time to do a coffee, or first coffee. Okay? It will take a little bit. I figure out that if you turn off the antivirus software and all these things, it might go a bit faster. Okay? But we'll see. For me, it takes time, yeah. If you have lots of fails, that's not good. So that means that it doesn't find the compiler. Yeah, if there are some fails, it's okay. Okay? But for instance, the first line, check for a working C compiler should be working. Okay? If that's the most important thing. Some other, these are things like, if there are a lot of fails, but it's because of his checking some tags, let's say, of the compiler, that's okay. Okay?
Something is failing.
You'll see that in my case, there are some no's, but there are some yes, and they're doing things. This is so far so good. Okay? So now this is trying to configure, is trying to generate the files, or check that everything is okay to generate the files for Visual Studio, whatever compiler you have.
So what's happening now?
Now it's checking all these things. Okay? And then you have to click, once it's finished, to click on generate. And generate will take the source code for ITK and generate in the case of Visual Studio, the solution files or the project files that you need to compile.
So the mission of CMake is to change the format, can I say?
Yeah, it's to make it, because it's cross-platform, the source code, CMake will generate the specific files
The appropriate type.
for the compiler and the hardware or the software or the operating system that you have.
Okay, to make it portable. Like
Yeah,
this
the
file.
CMake is the key here to make it cross-platform.
Okay.
Yeah, it kind of takes general source code that it's going to be valid for any platform. General source code to the specific solutions.
It's similar to what is called Java virtual machine, but that one in Java, like changing bytecodes and instructions to any platform.
Yeah.
Something similar.
Yeah, something similar in the. It's not exactly the same because Java is an interpreted language. Okay, so it interprets line by line, let's say.
I mean the concept.
But the concept is the same. Your general Java is cross-platform as well, and the Java virtual machine, what it takes is the source code in order to execute it in a particular machine. So it's similar. It's a similar concept. Yes. Okay, so I'm trying to talk a little bit to make it finish, but it's not finishing. So what else we can say? No, but it's, as I said, it should take a bit of time, and sometimes it takes time because of this Windows Defender thing. So if I can,
Stop everything.
there's a way to kill him. Protecting, yeah. If I do that, probably will finishes quicker. Because the thing is that it's checking lots of files. So if it's checking lots of files, the defender wants to also check that the files are correct, etc., etc.
These are suggestions from the web.
Sometimes. Okay. Has anyone finished configuring? Yes, so you have faster computer than me. So after you click on configure, you click on generate.
Okay.
Yeah, you should click on generate. Once you click on generate, okay, you'll see that you should have a bin folder, if you call it bin in the CMake. So this bin, is the same as this bin here. Yeah? So if you call it bin, should be a bin file here. And here is where all, let's say, platform-dependent files are stored. Okay? This is really important to have separate binary from source code. Okay? Because if you compile for another platform, you will generate another bin. You don't touch the source code. If you put everything together, that's some errors that you could do. Set the same source and the same bin folders the same, you might have a mess of folders then. You have to go file by file and seeing which one is depending on your platform. So it's not a very good thing to do. And basically here you don't have to look at much things, okay? You only have to look at in this case, if it's Visual Studio ITK.sln, the solution that they call in Visual Studio, you load that. In Visual Studio, I think I loaded that before. Well, lots of things going on. Once you load it, you'll see, let me close, and you'll see that I open the solution, we'll open the Visual C, and we'll load the whole ITK, so it's loading, well, it didn't take that long, but it's loading like 500 or 600 models, different models, okay? So you could see all the ITK here libraries. So this is the big stuff, all right? But there's no need to look into anything, just load, all right? Remember that I said something about compiling for debug and compiling for release, okay? Remember now we are compiling the libraries, not our source code, not the hello world or any source code, just the library. So the idea is once the CMake has finished, you do the configure, you load the solution, and then you can compile. You can compile for debug. I don't know if you see it. If I make bigger, it doesn't make big the other things. Mm-hmm. But here you can select debug or you can select release. Okay? Up to you. Maybe if you don't want to take too much space, you can select straight away release. And then you will do a build solution, or F7 in that case. And then there's the second coffee that you need to take. Okay? And this is really a large one. For me, it will be quite quick because I already did the compilation. So I think, wow, that's really nice. It stopped building. Maybe it's because we're messing up with CMake, probably. Okay, that's nice. Well, in principle should work like this. Okay, so and that's what it takes most time to compile. That could take from 15 minutes if you have a very powerful machine to 2 hours. Okay, that's good because we go for lunch, so you can let it run for a little bit. Okay, if we don't finish, that's also good that we only do 2 hours. If we don't finish in an hour, you can let it this afternoon compile, and tomorrow we'll see what is the output. That's the most time-consuming thing that we're going to do. So if this works, then compiling for Hello World, it's immediate. Okay? But I thought it was going to be a good exercise to try what is CMake, to try how to compile, and see that once you download something that's a binary, well, it's because somebody else has done that in your particular platform. Okay? Mm-hmm. So I thought it was a good exercise as well. So at the end, configuring has been done, and then I type in generate. So now I'm going back there. Remember that configuring was checking all the things, and generate is quite quick to do. And then you can click on open project, and we will open the solution that I was saying. Okay? Mm-hmm. Hopefully now with all this should work. It's loading, will take some time to load and some time to compile. Okay, so I think it's now time for you to try all these things up to the Hello World example. The Hello World example is already there as well in the examples Hello World. So you do not need to retype everything. So you can download already the CMake list and the Hello World. Don't download the bin. Okay, we're going to talk about this. The bin is where the executables are stored as well. So in the Hello World, you'll do the same thing as we do in ITK. Source code in one side, binaries in the other side, in the other folder. Okay? But let's wait for the Hello World. First, try to everybody to compile ITK libraries and see if they work, and then we'll discuss about the Hello World. Okay? I'll stop the recording because I'll move around. Okay, so you have your program will follow a structure based on the data. So you load an image, you pass this information to the image to a filter. The output of a filter will go to another filter, segmentation algorithm. It can be written to an image file, etc. It's also multi-threading, so you can have different threads to make it more efficient. You can handle exceptions, you can have events, and you can have also some GUI programming. And in addition, because you're going to do Python programming in this afternoon and the following days, there's a wrapper for Python as well. Okay, and you could say you should have told that before going to C++, but I think it's a good experience to learn C++. You learn Python as well.
I think when we built, we didn't check.
You didn't check the Python, but even if even if you did not check the Python, when you have your Python environment, you can easily install ITK, like pip install. You'll see that when you do Python, but it's very easy to install and remove files. Okay, but the idea is the same. You will have a Python software that is going to be wrapping these libraries. That the libraries are done in C++. Okay. And obviously, it's a bit faster to work in C++ than it's going to be in Python. Okay. Okay. So just a comment. I've commented a little bit about how ITK is a structure. It's following the templates as I was saying. Okay. So you can have the STL or standard template library, not ITK, but it's standard C++. You can have, for instance, a vector of ints, double, chars, etc. Okay, so it's the same object, you just instantiate differently. All right. So ITK will follow the same idea. You'll have an image, and as I said, you can have an image. It has pixel type and dimension, so you can have an image of chars of two dimensions, of characters of 3 dimensions, 4, etc. RGBs, unsigned, even an image of vectors. Okay? Yeah? So each pixel is not a single value, but a vector. That could be also the case. Alright? And this is, at the beginning, can be a bit confusing, but it's quite powerful. Okay? Because with the same object, ITK image, you can have instances of different types. Okay? And each of those will be with this magic keyword typedef. Typedef image char2. That will be my name of the 2D image. Okay. So to avoid any problems, what we used to do is to add the namespace explicitly in each of the classes that we have. Okay. So that means if it's an ITK class, we'll use ITK semicolon semicolon and the name of the thing we're using. ITK image, ITK blah blah. Okay. This in principle could be avoided, but this also avoids a lot of confusion that if you have something called, for instance, statistics in another C++ library or another library you're using, for instance, if you're using computer vision libraries, then it can have a conflict. So if you are used to put namespace, that will clarify things to the compiler and will avoid lots of errors, compiling errors that you don't know where it comes from, but it's a matter of that he's trying to look for another class name that is different. Those, by the way, those slides are from the ITK tutorials, okay? But I think there's no need to redo them again because they're very, very well explained, okay? So, and they say something which is very true, which is what your favorite keyword will be typedef, okay? Mm-hmm. In the sense that you're going to see it everywhere in ITK. We already seen the hello world example where we were saying typedef, ITK, char2, image type. Okay? When we will use a filter, that will be the same thing. Typedef, ITK, the name of the filter that you use. And because it's a filter, it has an input and an output. Of what? Of images. Okay? So because we defined image type before, you can say, okay, image filter of image type and image type. Yeah? That will be a filter. Inputs an image, outputs an image, and do something to the image. And this is going to be a filter type. Okay? Otherwise, if you don't want to use typedef, you can do this. Yeah? But this is, for one line it's okay, but if you have a full, source code on that, that could be a bit of annoying to start writing. Every time you want to use an image, you have to write image, char2 image. That is very prone to errors. So I would suggest to stick to the first notation here. Anything that you are using from ITK, just use a typedef and put a name. It's much easier and you are much robust to not having errors. Okay? Smart pointers, that I think I was saying at the beginning as well when we looked at the hello world, okay? When you create with a new, you create a pointer to the object, but it's a smart pointer. It works? Okay, I thought you were jumping. So, every time you do a new, it has a count of how many pointers you are using, okay? Once you don't use this pointer anymore, it's kind of counting the name of references that they have. When they reach to 0, it deletes it from memory. What I'm saying here is that it's smart. You only have to do new, you don't have to delete it. Okay? So this is what it explains here. For instance, you have image type, filter type, and you create the filter. You need to create a filter before using it. Does it make sense? Yeah? I need to create the image. Yeah? And I can do things like this. Whatever comes out from the filter, this is a very typical way to use the filters. I get the output of the filter, and I put that in this variable image. Yeah? This is not the full source code. Okay? You have loaded the image before, you have done something in the image, you have your filter, and that's the way you connect things. Okay? Before that, it will be a filter, get input or set input, and you will put an image as set input. We'll see an example for that. This is just an example of how smart pointers is. There's no need to do filter delete. Okay? This is done automatically. Okay? Is everybody comfortable with this code, more or less? No? Okay? Is it clear these two type defs? Declare an image of chars of 2 dimensions, and we call it image type. Okay? Then another type def on a general filter, okay, that takes as an input the image type and takes as output the image type, another image, let's say, of the same type. And we call it filter type. Okay? Before using the filter, we need to create it. So we'll do a new. Filter type, we have to, because we're using pointer, it will be pointer. We call it filter, that's the variable. Filter type, 2 semicolons, new. We're creating the filter. After this instruction, we can use the filter. Okay? Okay? And then what this line is doing is creating an image. We are not doing image type, 2 semicolons, new. Okay? What we're doing is, because we have a filter that provides an output, we assign to this image the output of the filter.
When did you give the image to the filter?
The input, we haven't done it. Okay? That's just a piece of code. That is not the entire thing. We're going to see that in a minute. An example. Okay? But this is more on the basis of how smart pointers work. You create a new, and there's no need to do a delete of the filter in this case. Okay? More or less? Understood? Okay, knowing constancy is inside, not knowing constancy leads to disaster. Okay, that's something to remind. Anyway, I don't know if I want to go here. Well, you could put, instead of only pointer, you could use const pointers. Okay? If you put const instead of pointer, that means that it's a pointer which is constant. So you cannot modify things in the object. Well, this is probably complicating things a bit. Okay? We'll see when we do the examples. Example of data pipeline, for instance. Okay? You have your image, you have your filter. This filter has an input and an output. So the idea of you create a new image, you'll load it, for instance, from a file. You'll create your filter and you will say, okay, the image I load, the input will be this image. The output of the filter will go into, for instance, another filter. You could do that. Okay? And then you can save this to an image. Okay? Each of those blocks will involve different parts of ITK. This loading an image will be a block or an object called image reader. Okay? This will involve the filter. This will be involving another filter, and this probably will involve image writer. Something that will write the image into the specific file. Okay? So this is a typical example. Well, I'll skip this, but you can say from an image you can use the full image, you can use a small part of the image, you can use several things as well. Okay? This is the most easy, now with the specific names, the most easy data flow, which is applying a filter. Let's say a gradient filter. You want to extract the gradient. You know what the gradient is? Yes. No? What is the gradient?
Is the derivative of the image?
The first derivative? Of?
First, second, whatever.
Okay. So what do you use gradient for?
For edges? Maybe?
For edges, for instance. Okay? So you'll see, let's suppose you want to do ITK edge detection. There are filters to do edge detection, and there's one specific one which is called gradient. So you go and search for the specific name, and you'll see that it's called ITK image gradient or something like this. You will load the image. For instance, here you have the image file. You will use this image file reader, which is loading the image from the file to a memory, to an image object. You will set the input of this filter, of the gradient filter. You will set the output to another image, and you will write this into a file. And then you have your gradient image. Okay? We'll see an example of that. That's after the hello world example, we'll do this filter example. Okay? Image file reader it's what you're going to use, but if you see the specific details of the image file reader, you'll see that you can read PNG's image, analyze image, VTK image, Datacom image, etc., etc. Okay? So that's quite powerful from ITK as well, that you don't have to focus, for instance, on which format is your image, is that a file reader will see what is the type of the image you want to read and will automatically read the image. Okay? So let's imagine the new format comes in, then ITK will have another box here for this particular image. Okay? But it will be quite transparent to your source code as well. Okay, so this is an example of reading and writing an image. Okay? Only this. Reading and writing an image. Let's see if this is a full source code now. Not as before, there was some parts of the code, but it's a full source code, okay? Okay, so include files, because we want to use the image, we'll include ITK image. Because we want to use the file reader, ITK image file reader, and ITK file writer. Why? Because those, if you don't put them and you use the filters themselves, the compiler is going to complain. Okay, you will go to the ITK, let's say, model list, and you say, you have to include this include file. That's it. Okay. Let's say, hated type defs, 3 of them. We put them after the includes, because that will be a general thing for all the source code. Okay? Okay, I'm going to use images of characters of 2 dimensions. So I call it image type here. Okay? I'm going to use a file reader of the image I declared here to read the image. Again, here you can put the name whatever you want. Okay? What is meaningful for you. Reader and writer. Okay? Yeah? After declaring this, we need to have the variables or the objects to do what we want to do. In that sense, reader type, pointer, reader, new reader. Yeah? Writer type, pointer, writer, new writer. Okay? So now we created the objects for reading and for writing. Okay? But we haven't specified which file, etc., etc. We do it afterwards. Because it's a pointer, you know that you can set like this in C++, reader pointing to an method of this reader. You know that? So reader set file name, the name of the file you want to read. Just imagine that we have an input image called like this, input image.dcm. Okay? And then the writer will be where do we want to write the name of the file we want to write. It will be output image. It's another file. It's not DICOM, it's an analyze file, header file, it's called. Yeah? Just saying, look, this is quite powerful. Just saying the extension, ITK will know the format you want to write to, and then he will write it correctly. Okay? What else? The writer, you need to connect. You have a reader, you have a writer. Okay? You have to connect this reader with this writer. Otherwise, the writer doesn't know what to write. Okay? So, by the way to connect to filters or to objects in ITK is to put set input of one filter, the output of the other one. Okay? So, look, here is how you connect things. Reader, that is reading the image, you say get output, get what is the output of this filter, which is reading the image, and you put it in the set input of the writer. Okay? That's the most complicated thing in ITK. So if you understand this, all things you do in ITK is just setting inputs from one, outputs from the other one. And you can complicate things as much as you want. Okay? Last thing you need to do, because here, if you don't do this update, we don't tell the writer to work, let's say, to execute. Okay? Once you set all the, let's say, the pipeline, you have to execute last things to say update. And when you do update, after this line, it will read the image, it will put it in the writer and write it into the file. Okay? Does it make sense, this source code? More or less?
Yep.
Any questions, things that are not clear? Yes. Let's, and I'll do it on the board. You have your image called input. This here. Okay? Yeah. To read things into ITK, you need a reader. An object called reader. Yeah? Let's imagine that we want to take this VCM image and convert it to another format, like here, to HDR, to analyze format. Okay? Yeah? So the reader, as we have here, has a set file name. Yeah, something inside this. If you look at the reader, let me check. Maybe we can look at. You can go and see for reader. TK. Okay, if you don't find it, you can always search for it, okay? ITK image file reader, okay? There's a lot of things, complicated things. But here, you can see that the ITK has some functions, okay? And one will be set file name. That is the file name you want to read. So if you want to know image file name, file reader, where is it? Gets a bit messy at some point. Well, we'll find image file reader construction. Okay, set file name here. You input a string. Okay, so you will input here the file name. Okay, so putting input.dcm will tell this reader that you want to read this image. Okay, we want to write it somewhere. You will need a file writer. Okay, that will write it on the disk. Okay, how you say to the file writer which name you want to give to the file that you are reading? You use the method set file name. Different methods. This is from this one, this is from the other one, although they're called the same. And I call it output.hdr, or you can call it whatever you want. That will be the file that is going to be saved. Okay? But now those two things are not connected. So if you run like this, only those two things without this line, let's say, and you click and you do write and update, yes, you're going to generate an output from the image, but it's going to be empty. Okay? Might have also some errors there when executing. Okay? Why? Because you didn't tell to link those two. Okay? A way to link things in ITK, it's some sort of simple when you're used to it, is say, okay, this has a method called get output. Okay? When you do reader get output, this will give you the image. Yeah? You just have to put this get output, something like this. It has a method that is called set input. If you want to connect those two, you just have to put the writer set input, the output of this. Does it make sense?
Yep.
No? Yes?
Yes.
Who doesn't
Question.
Yeah.
The scope is usually used with namespaces, but
Yes.
here it's used with a type. So, like we are saying, image type, or
Yeah,
yes.
this is a name that you give to all these things.
Yes, but with reader type, it's a type, and we are using down reader type scope new. So
Yeah, because you need to declare any objects that you use, you need to declare as new. Everything. So in all your ITK code, you will have type defs for all things you want to use, and almost new for all the filters or objects that you want to use. Okay? Lines of different news and lines of different type defs. Does it make sense? And then you will start putting parameters to the different blocks. To the reader, I'll put the input. To the writer, I'll put the output. If I have a filter, Gaussian filter, or gradient filter, the parameters of the gradient filter, etc., etc. Then I will link the different models. Yeah? Input with this filter, the output of the other filter, etc., and then I will put update to the last one of the filters or the objects. I know it's not easy, but it's the way it's structured. It's quite powerful, because if you want to add something else, you just have to have a new line like this to change the input and the outputs, and that's it. Okay. Does it make sense? Everything is in, all those slides are also in the Google Drive. Okay? So that's an example of reading and writing an image. There are other things we can do. Probably it's a bit beyond the scope of this short course on ITK, but you can also do error management with exception. You know exceptions in C++, in other languages as well. There is a try-catch sections, yeah? So you can do things like this. Try to apply a filter, but if it doesn't work for any particular reason, then you can do a message. Okay? As said, probably we're not going to use that in those 2-3 days, but if you're continuing to work with ITK, just for you to remember that you can do these things. So error management, it's quite easy and powerful that way, so that you make sure that all in your source code, all the filters that you are executing are working properly or not. Okay? Don't assume that everything works. Okay? You can also put observers. Observer is something that tells you how the filter is behaving, for instance. Okay? You could know, it's useful for debugging. Okay? Just imagine that you have an iterative process to do, many Gaussian smoothings and things like this, or many computations on your image. You could put some small parts of code that are executed every time something is computed. Okay? It's good for debugging and all these things. Again, this falls a bit of the scope of this short course of an ITK, but it's quite powerful on doing all these sort of things. Okay? And you can have events, and this is very powerful to link to if you do a GUI, a graphical interface. You click a button, then you communicate with your ITK source code, etc., etc. Again, these are advanced things, but I think it's good to know that it's not only applying filters. Okay? So you can have very, let's say, events-driven applications as well. It's not only the main, a main that is executed line by line and it finishes. You can have your program stop at some point until an event has been placed. Okay? So things like this, GUI communication with those observers and events, it's quite common as well, and that will be it, I think. I think it's 3 minutes to 1, so I think I will leave it here. I put some homework for you, which is trying to compile the Hello World example. Okay? It should, if everything works as expected, it should take less than 5 minutes. Okay? Just to comment how you would do the Hello World compilation. If everything works as planned, you have your Hello World example somewhere. Okay? To compile, you need CMake as well. Okay? So basically, you will go to find where your source code now of your Hello World example is, which in my case I completely forgot. I think is somewhere here. Yeah, Hello World. And you probably won't have the bin yet because you are going to generate it with the CMake. Okay? So you just select the Hello World. Okay? And you can select the Hello World because you have the source code here, the Hello World source code, but also the CMake list. You remember the CMake list? That it was the file saying, I'm going to create a project called Hello World. I'm going to use ITK. Okay? And I'm going to generate a Hello World executable from compiling this C++ code. And I'm going to link it with the Hello World library, with the ITK libraries.
Is it a language, like programming language? Or?
This is what the CMake uses to compile. It's kind of a language if you want, but it's very simple. It's just telling the CMake what libraries do we need to use and where is your source code, etc., etc. Yeah? So CMake, I'm linking this to this because once you go to browse to this, CMake is looking for a CMake list for this file. Okay? And now he's found it. Let's say I remove this. There's no CMake. And I tell him, go here. Well, now because it's in the cache, I can remove that. Once I click on configure, well, why is this generating? Okay. It's an error. When you try to generate without a CMake list, it's not gonna. It says it does not appear to contain a CMake list. Okay. So if I go back to my hello world now and I put the CMake list back there, okay. CMake list and source code here. I go here and I say configure. Nope, sorry. No, I didn't want to do that. Hello world, but also hello world /bin, where I want to save my files. Don't put the same. Or bin 2, for instance, okay? A folder that doesn't exist, okay? So I type in configure, and it says, this doesn't exist. Do you want to create? I say yes. Which compiler I use? It takes a bit of time, as before, okay? I'll go quick. But you see that this has created the bin2 file, okay? Which will be the same as this one. It will create a Visual C++ solution. So if I open this solution, you will see the hello world example here. Okay? You modify whatever you want. Hello casino. And I debug. Or I can run it if you want for release. If you have release, you have to run for release. Compiles. It doesn't take as long, okay? Well, it doesn't run the example, but you can run it from... But the important bit here is that it succeeded, okay? 2 succeeded, 0 failed. So you can go to the folder, which is inside the bin. You'll have a debug or a release folder, depending on what you compile for. And then I can type in, sorry. You know bit command line? Yes, more or less. You only need cd and there and things like this. I can type in hello world. And if everything goes as planned, it's not saying hello world casino. Why not?
Because bin 1 is not bin 2.
Sorry?
You are not going bin 2.
No, but bin2 I haven't used it yet. It's because I'm not in release. I compile for release. So it should be somewhere called release. It's not there. Bugger. Then I compile for release. Build solution. Should be there. Sorry? Because that you were right. You were right. No, what are you?
You are using bin. Bin 2 wasn't completed, I think.
But I click on open from this one. I think I did quite a big mess here.
And you didn't build in Visual Field. You right click on Hello World and set a start of project.
Sorry?
The old field is not working on the right on the solution, Visual Studio.
Mm-hmm.
In the solution panel on the right click on Hello World.
Yeah?
And now the main one, project one, on top.
What do you mean?
Old build, just below old build. Yes, right click. Below old build.
No, hello world.
But I think it's done, no?
No, the old is not working. Here, just below on the Hello World project. Right
Just
click,
this one?
Set up a started project.
Okay.
And then control F5. Yeah, if you control F5, now it will work.
You know more than me. Hello casino. Woohoo. Okay. So apparently it didn't build, but it should have built at least release, debug. That's strange. Build solution. Because if you go here, not bin, should be bin. in debug should be hello world 21st. No. Well, that's homework for me as well, because it's a bit strange I didn't compile. Where did it say it? I think we messed it up a little bit with this bin and bin2. I will check. But in that sense, in your case, okay, you should have inside debug, if you compile for debug, an executable, okay, and inside, if you use release, you should have here the executable named hello world as well. Okay? So, is it more or less clear? Yeah? So, I would say, let's meet tomorrow. I think it's first thing in the morning, maybe? I don't know. We'll check. Depending on the schedule. The first thing we're going to do is to see if everybody has been able to run hello world. Alright? So that will be our starting point, then to try new, more interesting things. Okay? Okay, so see you tomorrow.